How's it, guys? So this is just a video recapping the long question. Again, as always, doing the long questions, or that you attempt the long questions, is vitally important, even though we don't grade it every week. But if you're practicing the long question every week, you're on track to be ready for the final exam. So by the time we get to the final exam, you effectively 90% have studied. I just want to encourage you to please do the long questions every week, and then the week after check out the recap video of the long question. Alright, so this week's long question was on ABC, obviously, and the required of this question was we need to calculate the cost per unit of each product based on the traditional system, and part 2 based on the activity-based system. Alright, so we're given information. We have two products A and B. They currently absorb manufacturing over using machine hours, so that machine hours is the normal allocation base, in other words, the traditional base. We produce 1,600 units of A and 1,200 units of B. The cost per unit is, for product A is 55 for material, 30 for labor, and B 62 for material, 25 for labor. Machine hour consumption per unit is 4 and 3 respectively. And then they give us some information here. The two products are similar and are produced in runs of 40 units for product A and 20 units per batch for product B. They give us total production overheads, and they considering switching to ABC, and they have different components of overheads there, as well as the respective cost drivers and some information on number of requisitions for product A versus product B, and number of orders executed for product A versus product B. Alright, so in this video I'm going to run through the traditional cost system, and I just want to remind you of the steps, which is in your notes right up front. Step 1, find the total overhead costs. So total overhead costs in this question is, there we have it, 293,800. So that's step 1. Then we know step 2 is, what is the normal allocation base, or how do they allocate overheads? Well, they're telling us it's based on machine hours. Okay, so then the next step would be, so the next step would be step 3. The normal allocation machine hours. So step 3 would be, what is total machine hours? So where we get that total machine hours, well, product A uses 4 machine hours, so it's 1,600 times 4, plus product B uses 3 hours times 1,200. So that will give you, to show you as per the solution, that will give you total machine hours 6,400 for product A, 1,600 times 4, and 3,600 for product B. So in total, that's 10,000 machine hours. And then let's just remind you of the next step. So the next step would be to determine the overhead rate by taking the total overhead cost in step 1, dividing by the total allocation base. So that would be, we define that the total overheads is 293,800. The total allocation base is 10,000. So then the rate will be 2938, and then the final step is we need to allocate this 2938 to the products. So remember, that's 2938 per hour, machine hour. Product A uses 4 machine hours, so it's effectively that times 4, and product B uses 3 machine hours, so it's that times 3, which gives you 88. Alright, then so the overhead allocation, so remember, total cost per unit is typically material, labor, and overhead. This is material and labor is easy because it was given. However, we needed to allocate the overhead, so it's 117, which comes from there for product A, and 88, which comes from there for product B. And as I said, these costs were given in the scenario, so that's self-explanatory. So when you add material, labor, overheads, you get total cost. So it's that total, it's 202 for product A, and that total 175 for product B. Cool, and that is the traditional method. So next video, we'll come back and do the ABC method. Thanks. Cheers.